Okay, this is the P4 paper from June 2023. Question number 6, and this is an integration question, but in particular we're going to be modelling differential equations. So let's have a look at it and see what we've got. It tells me the temperature of a car, temperature theta of a car, T minutes after the engine's turned off is modelled by this differential equation. And so we've got a constant here in the differential equation. It then tells me that two pieces of information, temperature is 85 at the instant the engine is turned off. So that's going to be when T equals 0, which means that when I do my integration and I have a constant of integration, I should be able to work that out using the first piece of information. And then it also tells me that it's 40 degrees when T is equal to 10. So I think that's going to enable me to work out K. But if we get started, we'll see how that all works out. And then it says, can we solve the differential equation? Which, yeah, I should hopefully be able to do. But I can see already that I might need to do a little bit of extra work to get it in the format of theta equals whatever we've got there, AT plus B over CT plus D. Right, let's actually make a start, though. So it says, we were told that d theta by dt was equal to minus k theta minus 15 squared. So this is separating the variable. We're going to get all the thetas onto one side and everything involving t onto the other side, which in this case is going to make us have d theta over theta minus 15 squared is going to be equal to just minus k dt on this side. So now that we've got them with the variable separated, we can just integrate. I'm not going to spend too long doing this one, but if I've got the left-hand side, if I've got theta minus 15, well, I've got 1 over theta minus 15 squared, that's the same as theta minus 15 to the minus 2. And this is one where we can just use reverse chain rule to work out what the answer is going to be. I can see that if I differentiated and the power became minus 2, my guess would be that I started off with y equals theta minus 15 to the minus 1. When I differentiate that, then dy by d theta works out to be multiplied by the power, take 1 off the power, multiplied by the differential of what's in there, but that's the whole point, the differential of what's in there is only 1. So we get that the integral of minus theta minus 15 to the minus 2, the integral of that would give me that. I haven't got minus, I've got the plus of that. So I'm straight away going to say, okay, so sorry, getting rid of the integral sign then, this is minus theta minus 15 to the minus 1 is equal to, integrating on the other side, minus kt plus my constant now. And then it's up to you whether you want, whether you want to actually leave all this as part of your, actually no, why not, we might as well just leave it in there now that I've done it. But normally I'd just get rid of that. I wouldn't take any time over that part. But here, so at this stage, we've got minus kt plus c here. And then we knew we were going to get that. Remember when I started off, I said the first piece of information, which was t equals 0, theta is equal to 85. Well, if I put that information in, the k will disappear, so I'll only have c as my constant here. So putting that information in, I get minus 85 minus 15 to the minus 1 is equal to minus k, but multiplied by 0 here, plus c, so I can get what c works out to be, and that's minus 1 over 70 on this side is equal to c on that side. Right, okay, so my equation up here then can now change and can be minus theta minus 15 to the minus 1. Well, I'm going to tidy that up. That's minus 1 over theta minus 15. That is equal to minus kt minus 1 over 70. So I'll now use the second part of the information. Before I do that, let's tidy that up, because I can get rid of all those negatives, can't I, and just make it a little bit easier when I'm going to be doing my algebra. That's the same as 1 over theta minus 15 then is equal to kt plus 1 over 70. I've literally just multiplied everything by -1 there. And then there was the so I've used that piece of information. There's a second piece of information here, which tells me t equals 10 when theta equals 40. So put that in when t equals 10, theta equals 40. This is how I'm going to get my k. So if theta equals 40, I'm going to get 1 over 40 minus 15 is equal to 10k plus 1 over 70. So 10k will be, what's that, 1 over 25? 1 over 25 minus 1 over 70. And from that, k works out to be 9 over 3,500. So again, going back to this equation here, I now know what k is as well. So I can say 1 over theta minus 15 is equal to 9 over 3,500, or I'm going to write that like that, 9t over 3,500 plus 1 over 70. Well, that'd be perfect, but we've got to have it as theta equals. Not too difficult to do, but just take your time and get this sorted out. What I'm going to do is turn this into one fraction first of all. Once I've turned it into one fraction, I'm going to flip both of them upside down. Well, let's just do it rather than saying what I'm going to do. 1 over theta minus 15 is equal to 9t over 3,500 plus, well, let's make that 50 over 3,500. So we just make it the same denominator there. So 1 over theta minus 15 is equal to 9t plus 50 over 3,500. You can do this much quicker if you want to, as long as you're showing some of you working out as we're going through. Let's say this is what I was getting to. I'm going to flip this upside down now. So theta minus 15 is equal to 3,500 over 9t plus 50. And so theta is equal to 3,500 over 9t plus 50 plus 15. But even that, it's not quite in the right format now. They wanted it as a single fraction here. So again, just turn this into a fraction. Theta over 3,500 over 9t, excuse me, handwriting, 9t plus 50 plus 15, and then 9t plus 50 all over 9t plus 50. So what's that going to work out to be? That's going to work out to be theta is equal to 3,500 plus 135t there, plus 750 all over 9t plus 50, nearly there to the answer. Theta is going to be equal to, that works out to be 4,250 plus 135t all over 9t plus 50. And if we now go back and look at the original question, yeah, in the right sort of format that I wanted there for that one. So that's part A done. What does part B ask? Hence, finding according to the model the time taken for the temperature of the car to reach 20 degrees C, and give your answer to the nearest minute when we get that far. Not surprising that they asked me, once I've got one of these equations, no matter how difficult the equation is, to just sub something in and use it. In this case, actually, it's not too bad, because it's just saying theta is equal to 20. Okay, so 20 is equal to 4250 plus 135t all over 9t plus 50. That's just really straightforward compared to what we could have had with previous questions. Multiply that up. We're going to get, what we're going to get, 180t plus 1,000 is equal to 4250 plus 135t. So just get t's on one side. 180t minus 135t is equal to 4250 minus 1,000 there. So what's that? 45t works out to be equal to 3250. So t is that divided by that, and remember they wanted it to the nearest minute there. So really not a bad question at all in terms of that could have been much harder for our modelling with differential equations. Hopefully that all makes sense to you.